That's how it is. Okay, radical equations. So we're solving equations and with radicals in them, just like we solved rationals. You know, they have fractions. So these are just techniques to solve equations with radicals. All right. So there are situations you come up with. You have to be a problem solver here. So let's see. So this is an example of a radical equation.
Yay.
Okay. This is probably the more straightforward version. But they're radical. It's a cube root. So right now, we're not going to cube it because we have two common terms here, like terms, so we need to combine first. So we're going to subtract 8 first. So we have -4. So isolate the radical. That's your first. That's your first thing to do. If you can. I'm going to show you a couple that a little funny. Okay, is this possible? The negative out of a cube root?
Yes.
Wait,
Maybe.
yes.
Oh no, it's a cube root. So
So this is what you consider here. If this was a square root, is this possible?
No.
No. Is it possible for a cube root?
Yeah.
It is. Right? What's the cube root of -8? Yeah, it is. So it can happen with odd numbered roots. Negatives are okay.
Why wouldn't you just cube 4?
That's what we're doing. So we're getting rid of this with the. These are inverse functions, the cube root and the cubic, right? They're inverses, so they undo each other.
So it's like -62, is that +4? 64.
And then simple linear subtract 2, right?
Yeah.
So -66. So the key there, isolate, and then cube or square or do whatever you need to do to get rid of that radical.
That's just your answer?
Now, am I done?
Yeah.
No.
Okay,
Just have to check
You
it.
gotta put all x. Why can't we just stop there?
If you check it, you might find that there's a negative in a square root or something, right? So, does 4 equal the cube root of -66 plus 2 plus 8? So this is -64.
That'd be -4. Yeah, -4 plus 8.
What?
Oh.
Okay, so it checks out, right? Good.
Plus 8.
Good.
So wait, what?
Wait.
Never mind.
So the cube root of -64 is 4?
It's -4. So, you know the relationship. So if I have 4 cubed is 64, correct?
Yeah.
Okay, so what is the cube root of 64? 4. Direct inverses. Okay, that's the relationship we're looking at here. Squareds of new square roots, cubes, cube roots, etc. Right? Okay, here's
You guys all over there. Is that x plus 10 or minus 10?
plus.
Like, you have multiple rows.
X plus 10. Here's a half and it's 3 straight minus 2. Okay, can I isolate that? This is isolated. This one? No, I can't do anything with this. Okay, so isolating the radical here as much as possible is done. Right?
Could you not add this to root 3 minus x, or does that not work?
You could, and it does not get you anywhere. Yeah, you could take this and move it over here, but it doesn't get you anywhere. Okay, so it actually adds a step to work. It's not necessary. All right, so how do we undo square roots? Where we square it. And this monster here is a FOIL. You have to FOIL this. This is where a lot of people get stuck, right? So on the left, you end up with x plus 10, right? On the right, it's there are 2 of them, so you have to FOIL. This is where, again, where a lot of people get stuck. Just follow the pattern foiling. You know, first, right? First times first. 25. And then outers, right? Five times 3 minus x. We're headed that direction. Yeah. First outer, now the inners, right? And then the last times the last, plus minus x. So that's where that root gets rid is gone. So what this does for us is it's gonna how many root 3 minus x is there here? Negative minus 5 and minus 5. Negative 10. Right. So we end up with
why is it plus 3 minus x, by the way?
root 3 minus x times root 3 minus x.
So the roots just cancel?
Well, it's
They're
squared.
both
There's 2 of
negative.
them, right? Negative times a negative is a positive.
Oh, okay. Okay, now.
2 roots of the same thing, the thing just comes out.
And would you want to
Very
add
mathematical.
3 and, or subtract 3 and add x?
With what thing?
See? Consider, it's easy to see some of this stuff if you boil it down to the simple version.
Yeah, I know.
Root 4 times root 4. What's the answer?
4.
4, because the
They ain't
square
no
root is
problem, they
16,
ain't no
right?
thing.
Well, that's what you have here. Inside is what comes out. Yeah, now we're gonna take all this stuff over to the left and isolate the radical. Now we can isolate the radical, because there's only one left, correct? It can, that's why you gotta stay organized. Right? Lots of you in here that are all over the place, it doesn't do you much good. So, add x, right?
Wait, question.
Yeah.
So right there above, like with the last 2 lines you just did, when you cancel out one of the 3 minus x, how do you still have the 3 minus x?
Here?
Yeah, when you cancel out one of
They
them?
cancel them. They add them. Negative 5 and negative 5 is negative 10. We combine the like terms.
So then why is it 6 minus x?
Because it's addition and subtraction. It's like saying I have 5 apples and I have 5 apples. How many apples do I have? 10.
He's what he's
And
asking.
like terms. This, consider that like an x.
So right there you're saying it's 3 apples and 3 apples, so how do you know how to say that?
Here.
Yeah. 3 plus 3.
Because
go
there's
down
a square
the-
root.
This is locked inside a gel cell. It cannot get out of here. You cannot add this to anything. You cannot add this to anything. Same thing here. These are like entities.
So ag.
like apples. You have to consider this an apple and that an apple, and then you just 5 minus 5. There you go.
If the square roots weren't the same, you wouldn't be able to add.
They have to be the same. Because we're not multiplying them together.
It's just adding them.
Alright, next. Add like terms, right? Minus 3 and minus 25.
Yeah.
Yeah, 2x minus 18.
Yeah, you wanna switch the negatives with my negative.
You know, it's not gonna matter because you're gonna square it.
So when you're isolating the radical, you have to do on the other side too. So like 25, that has to be gone.
Doesn't have to be, but I suggest
Okay.
if you don't want to end up with this again, if you don't move the 25, you're just here again. You got, okay, so move everything. Okay. Can I leave the 10? It's up to you guys.
Can we?
If I divide by 10, I get 2 tenths and 18 tenths, is that?
Let's just leave the number.
So we're gonna leave this, and it's okay, because when we square it, it's just gonna be 100.
Yeah, but wouldn't you have to, square it, wouldn't you have to boil the other side?
Or
too?
keep boiling.
I told you, these get messy.
That's straight up.
Nothing you
We
can't
should've
do.
done content today.
You just gotta follow the process. And square, you gotta boil it. Yeah. These are long problems. That's all they are.
That's all. Whatever we get into content.
So,
You got two.
What's each? Go to Abby.
No, she'll yell at you.
she won't.
Hey, you're gonna be 17 to get your dropout papers.
You only shut up about that.
Don't quit. What's 18 times 18?
A lot of big numbers.
Two
Big number.
296?
Sure. 24.
224.
Here's a calculator.
Sweet.
Yeah. Good math there. So we foiled. Check the I think it's right.
Where'd you get your
You have 2 minus 36 x's. You foil this. There are 2 of them.
Foil both sides? No. I'm sorry.
You guys are okay. He's okay. No worries. He's asking questions. You guys supposed to. There are 2 of them.
Why?
Right? So 4x squared minus 36x minus 36x. That's negative 7. And then 18 times 8 is. Well, shame on her. Okay, so I distributed.
Ah,
Yeah, if you weren't paying attention.
there we go.
You lost a break.
Good? Long problems. Welcome to math class. Now, move all this over here. It's quadratic, we have to equal 0. Combine like terms.
I thought when you had 100 extra, you'd have to divide.
minus 100x to move it, you can add 100. Okay.
What's that 103.24? I can't read that.
300.
Okay, the
Minus
3 looks like a 208.
That looks like 380.
So we're in a quadratic now. Two weeks ago we learned 4 techniques for solving
So you
those.
just divide everything by 4 and choose.
That would be my first shot. Greatest common factor of 4, right?
Yeah.
Divide by 4. Oh man, look at that. Now you can't see it. Bummer. That factor now? Yeah. Very easy to just factor, right? X plus 7. Let's do my math. Because I can
Plus
add.
6 next plus 1.
Pray that I don't really. So at, x is -1 or -6.
And then we have to plug that back
Now you-
Ugh.
Absolutely disgusting.
We have to plug that back into the original
I
equation.
take joy in you all.
And this is one friggin' problem.
One problem. I'm gonna venture a guess. Like processing through the rest of the year, I'm gonna boldly say this is probably the longest problem yet all year. Don't hold me to that. Probably. I qualify.
No, I think you're wrong.
Mr. Arthur?
Pretty sure.
So if you're going to check your problem, do you want us to do our work when we check, or can we just calculate or that?
We're just calculating that.
As long as you're checking it, I'm okay with the calculation. We'll back it out. So if I plug -1 in, I get 3. And I get 5 minus 2 is 3. So x -1 works, right? Yes. And then about -6, 2, and 2.
Wait, how'd you get 2? Square, right? Mr. Arthur? So because you got 2 the 6 minus the 4 and you divided it by 2 is the half?
This is 2.
Yes. How is it?
3 plus 6 is 9. 3, 5 minus 3 is.
I have a question.
There's a problem. So this is -6 plugged in. This is 2, right? This is, that's 4. The square root of 4 is 2. 5 minus the root of 9. 5 minus 3. Check, right? So they both work, actually. Yay! Sweet. Those are the 2 big ones I want you to see. So the two big things, isolate the radical, and then you might have to FOIL those radicals out. That's the big one for the day. Okay? Hunter.
Are all of our problems tonight gonna be that long?
Yes.
Yes.
But you only have like 2.
You don't do that.
There are only 2 people.
Automatically, I can say no without even looking at this, because all of them are not that long. Okay, let's see here.
Friday.
5, easy version. 7, not too bad.
I think it's 10 to 14. So 10, 11, 12, 13. I think it's like 16. Yeah, no, but we have to animate it. They're even.
What?
You have, one of the long ones. One of those really long ones.
Which is it?
Is it the even?
It's 15.
Oh.
Hey, it's an odd problem.
How many evens did I assign?
So pay attention to
It's not
those,
like I have like three.
because you're gonna have a,
pages of homework in there, so. Staying up till 1 again.
Tomorrow, I have a question. Tomorrow is modeling the polynomials. So think all-linear forms of parabola. You model that with data. My question is this: we can do a lesson. That's option 1, or option 2 is we can actually do like an experiment. Use the calculator to model that with a quadratic.
Let's do that one.
It involves bouncing a ball
Yeah, I'm
around.
kinda with the
We have
last
these
one.
sonic things that count how far it goes and how much time.
Yeah, let's do that. No, it's scary. Raise your hand.
Just, I want to do the experiment.
I want to do the experiment.
But it depends on you guys coming tomorrow with the right mindset.
Lesson.
You will learn. Okay? It's just like linear regression. Stat edit, stat count. I'm ready tomorrow to be on task. You have 5 minutes. You're foggy on the 2 hours. Help you one-on-one. I suggest trying a problem or 2.
I think I got hit too much in football, now I just can't look back.
Okay, so 50 is 2. 50 is